All right, so this is the 2023 Jan afternoon paper. So let's start with the first question. So the question here states that this is the help page of Echo, how Echo works. So we already know that -n is a flag that will not print the new line at the end after printing everything. And -e lets us print like backslash things like \t for tab, \n for new line, etc. So these are also listed out, what \n is and what \t is. So in this question, we are given this 4 echo statements where we have echo -ne in all of these. So -n means there won't be a \n after each echo unless we manually provide. So here you can see how after all of these, we have provided a \n. So this will basically be same as not giving the -n and not writing this. So after each line, it will go to the next line. And the E means we are able to provide these escape characters. So \t and \n. So here what we are doing, first we are printing A and then a tab and then B and then new line. So if our line is here, so first we print A, then a tab. So it will be around 8 spaces, and then B and then new line. So then we are coming to the next line. And then we are printing a tab and then C. So we have I think space and a tab and then C. So around 9 characters and then C. And then we print the new line again. Then again we have a space and a tab and D and new line. So in the next line we have space and tab and D and again new line. So we come to the fourth line. And there we have a space and a tab and then E and then again tab and F and new line. So space and a tab and then E and then again a tab and F and then new line. So this is what we are printing. So then it is asked what is the output. So this will be the output. So we will have A and B and then C and D with like leading tabs and then again tab E F. So that is the correct option, which is the answer. And we also have outputs like this. So these would have been true if we did not have the \n at the end. But because we have the \n, we are going into the new line after printing each of these. So this is the correct option. Hopefully this one is clear. So let's move on. So now we again have a cron question. So I'll not explain in details how to do this. So we have the minute, the hour, and the day of the month, month of the year, and day of the week. So here these two are stars, so they can be any values. And this is 0 and 4. So this is basically hour 4. So this is a 24-hour format. So hour 4 means 4 a.m. and minute is 0. So at 4:00, and the day of the week is said to be 1, which means Monday. So 0 is Sunday and 1 is Monday. So then we are running this. So at every Monday at 4 a.m. So that is the option B. So every Monday at 4 a.m. So that's how we solve the cron question. All right. So here in this next question, we are asked how many lines will the file b.txt have after the end of execution of the below command. So here what we are doing is we are running the sed command. So we are substituting dot star with that same thing. So ampersand basically is a symbol which means whatever that was matched. So here we are matching dot star. So whatever is matched in this, that thing will be replaced by that, followed by a new line, and again that. Right. So what are we doing? We are duplicating each line. Right. So we are dot star will match as much as possible. So it will match the entire line. So then we are replacing the entire line with the line and a new line and then again the line. So each line we are duplicating. So let us also see that in action. So let's say I have a file here.
Hello, sir. Is it recorded, sir?
Yeah, this is being recorded.
Can you give the link, sir? Recorded.
Yeah, so the link will be provided only after the recording is over. So you can go through the resources sheet where all the recording links are present.
Where it will be available?
I'm sending a link. You can go through the sheet. There all the links are present.
Okay, okay. Thank you.
So let me add a few lines here. Okay, so we have this file, and if we do this, so we are substituting the dot star. So if I simply do grep dot star, let us see what is matched. So on the data.txt, so you can see the entire line is matched. So dot means any character and star means any number of that any character. So grep dot star will match as many as possible. Right. So here we are matching the entire line. So when we are doing sed with substituting the entire line dot star with that line followed by new line and again that line. So then we are basically repeating the line 2 times. So you can see each line is duplicated 2 times. In this, what is the question? How many lines will the file be have? So here we are doing that on a.txt, and the output, instead of printing, we are redirecting that to b.txt. So how many lines will b.txt have? So if a has, let's say, 5 lines, how many lines will b have?
10 double lines.
Yeah, 10. No, double of the A. So that's why the option is D. Total number of lines in B is equal to twice the number of lines in A, because each line we are printing 2 times. Right? Hopefully this one is clear. Okay, so just give me 1 minute. I'll be back. Let me share my screen. Yeah, so this is how we solve this question. So we are matching the entire line, and then we are replacing that with that entire line and a new line, and again that entire line. So we are duplicating each line, and thus as many lines there are, the double of that will be the number of lines in b.txt. Right. So hopefully this one is clear. So let's move on. So in this question, we are given an awk script. So we are told in a working directory, a number of text files are present in varying sizes. So the file sizes can be anything, varying number of lines. For the following awk script executed in the working directory, what is true for the output from the following options? So here you can see this is similar to what we saw in the forenoon paper also. So we are setting a variable n, and we are every time for each line we are comparing if n is lesser than fnr. So what is fnr in awk?
The file line, right? The
Answer
number,
field
the
record.
number of the file.
Yes,
Current
the line number for that file. So for each file it'll reset. So for each file we are basically seeing the line number, and we're iterating line by line. So we're basically seeing if the file that file's line number is greater than n, then I'm storing n equals to that. So basically this is a maximum storing. So I'm storing what is the maximum FNR value, and also I'm also storing nf equals file name. So I'm storing the name of the file in which I found that maximum line number, and then in the end I'm printing that file name. So basically, given a few files, we are going over all the lines of all the files, and we are basically storing what is the maximum FNR. So FNR resets for each file. So maximum FNR is basically the file which has the most number of lines, and the value of FNR is the number of lines in that file. So in the end, we are basically printing the file which has most number of lines. So it is not the same as printing the file which has which occupies the most size, right? So for example, let me have here a file 1.txt where I have, so let me just do something like sec 100, which I store into file 1.txt. And let me also have another file, which is file 2.txt. And here, let me have something like this. So you can see the number of lines in file 1 is 100, and the number of lines in file 2 is only 5. But if we see the size, then file 1 is only 292 bytes, whereas file 2 is 1100 bytes. So The number of lines will not always say the size of the file, but it is only counting the number of lines. So it can be a rough estimate. So we are also given the man page of awk, like how the awk works. So then we have to choose what this is doing. So the first option is the file name that has the maximum number of lines among the files that are passed as arguments is printed. The second option is file name that has minimum number of lines among the files that are passed as arguments is printed. The third is the file name that is passed as the first argument is printed. And the fourth is the file name that is passed as the last argument is printed. So here what we are doing is we are printing the file that has the maximum number of lines. So here option 1 is the correct one. So I think this is by mistake marked as the fourth option. So in what case will the fourth option be correct, and this, like, with what change will this be correct? Like when will we always store the last file name, whether it's largest or not?
So if you, I guess, do it, we do like nf equal to file name within the end block.
Yeah, that is one thing. So if we do nf equals file name in the end block, that will only get the last file name. Another thing is, instead of fnr, if I do nr in both these cases, so nr is a monotonically increasing function, right? So it will never reset, so it keeps on increasing. So this condition will always be true. So for each new line, the nr will always be greater than the previous nr. So in that case, we will keep on basically assigning n equals nr and nf equals file name. So till the last line, we will be running this. So this will run for all lines, and thus we will always store the last file name. So if this was nr, then option 4 would have been correct. But here, because this is fnr, option 3 will be correct. So let us also run this. So here, if I have a script.awk, so here if I say n is lesser than fnr, then n equals fnr and file name equals file name. Or I think this was nf equals file name. And then in the end, we are doing print file name. Right, so this is, sorry, not this, file name. So, okay, so sorry, my bad. So actually this is the correct option. I saw this incorrectly. So in this, if we were printing the nf, then that would have been true. So first option would have been true. But yeah, so I didn't see this. Here we are printing the file name itself. Right. So as you also said, in the end, the file name will always be the file name of the last file. So here, if we are doing print nf, then we are always printing the file which has the most number of lines. But here, because we are not printing nf, we are printing the variable file name itself, which will just store the name of the file which is sent as the last file. So that's why here the fourth option is the correct option. There is nothing that is marked wrong. So let us also see both the outputs. So if I run this script.awk on, let's say, file 1 and file 2, so then I'm getting file 1. And if I run file 2 and file 1, then also I'm getting file 1, because here I'm printing nf, which always stores the name of the file which has the most number of lines. Whereas here, if I actually print the file name, so here I'm not even using the nf. So I'm directly printing the file name. So then I will always get file 1. So even if I put the file 1 as the first argument, then we will get, then we will always get the last files. So if file 1 is the last file, we get file 1. If file 2 is the last file, we get file 2. Right? So this is basically a faulty logic. So instead of nf, we have printed the file name. So that's why we are always printing the file which is passed as the last argument to the awk script. Right? Hopefully this is clear. So in two cases, this will print the last file. Another is if instead of fnr, we use nr. So in this case also, this will print file 2 if file 2 is the second argument, and it will print file 1 if file 1 is the second argument. And even if this is nf, so if this is nf, And you can see this is printing file1 and this is printing file2. So if this is nf and this is nr, then also it will print the last argument. And if this is fnr and this is file name, still it will print the last argument. Only if this is fnr and this is nf, then it will print the file which has the maximum number of lines.
Can I ask one very silly question here?
Yeah, sure.
Yeah, the difference between FNR and NR would be just that NR will give the number of lines in the file.
No, so NR gives the like total like running count of the number of lines. So if I have, let's say, 3 files, right? So we can see from this itself. So we have this file1, which has I think 100 lines. So this has 100 lines, and we have this file2, which has 5 lines, right? So for each line, so let me just remove this. For each line, if I simply print the NR, so I don't need this. So then you can see if I run the script on file1 and file2, so you can see it starts from 1, it goes till 100. Then also we had in file2, we had 5 more lines. So it goes 101, 102, 103, 104, 105. Right, so it is a running count, it never resets. So it will keep on increasing. Whereas FNR is the line number according to that file. So if I print the FNR, you can see it comes till 100, then it resets it for the second file, and again it prints 1, 2, 3, 4, 5. So that is the difference.
Then it resets for a new file.
Yes.
Okay.
Yeah. So in this, because we are simply printing the file name, so the option 4 is correct. If we were printing NF, then option 1 would be correct. So let's move on. So in this question, we are given the help of how xargs works, and then we are given output of how seq works, and also how what happens if you do seq5 xargs echo. So you take basically all the lines, give it as arguments to one echo command. So we will just get everything in one line. Also, the help page of ls is provided. So then the question is, where is the question? Okay. So select the bash function cmdlmf that opens the recently modified file in the current directory in vi editor. So we saw a very similar question in the afternoon session. So in this, we are telling that we will open the recently modified file. So in that, we were cding into the recently modified folder, but here we are opening the recently modified file in the vi editor. So in the first one, we are doing ls. So ls will simply print all the files in alphabetical order. So the order of output of ls is alphabetical with the name of the file. And there we are doing head -1. So we are getting the first file, and that we are piping into vi. So you cannot pipe something into vi. So you have to basically give the file name to vi. So multiple things wrong with this. First of all, we are just taking the first file in the alphabetical order, whereas we have to take the first file in the order of the modification. So as it's tell, we have to open the recently modified file. So when we sort the files by the time in which they were modified, then the first file we have to take, not the alphabetical sorting. And also we have to use the xargs to give the file to vi and not run this directly. So basically, how will we do it? So let us try to do it ourselves. So here we have a few files. So let me actually go into a folder. So right now we don't have any files here. So let me create a few files. So let me create A, and then let me create B, then let me create C, and then let me create B. So you can see there are 4 files, and if I simply use ls, so the output is in the order of the alphabetical order. So we are getting A, B, C, D. But if I want to print it in the order in which they were created, so I can use the -t flag.
M option. M.
No, M will fill with a comma separated list of entries. So if I want to print it in like the time, sorted by time, we can use the -t. It will print the newest first. So if I do ls -t, then you can see we are getting B, C, D, A. because that is the order I created. So I created A, D, C, B. So we are getting in that. So newest first. So A, D, C, B. So the newest is at top. So now if I pipe this to this output to head with -1 flag, then we get only the first line. So then we get the most recently modified file. Right. So there is one caveat to this. So what if the most recently modified file is not a file but a folder? So in that case, this will not work. So we will basically have to only print the files and not the folders. But if we are using ls, then this way, if we are using -t, then we can get the output in the time sorted order, and we can use head -1 to get the first. So now if I simply pipe this to vi, then this will not work, because it will try to read this as a command or something. So as you can see, b is not a editor command. So what we need to do is we need to pass this as a file. So we have to basically take this standard input and put this as an argument. So we have to basically run it as vib. So we can do that using xargs to build a command line. So I can say xargs vi, and what this will do is it will call vi with the argument b. So now you can, okay, so let me use vim instead of vi. So yeah, so now you can see that the vim has opened the file b. So you can see in the bottom, hopefully this is visible. So the file b has been opened. So this is the way to solve this. So you can basically do ls. One second, I think my terminal is frozen. So you have to basically do ls -t and then head -1. And you have to basically, for me, I have to use backslash because I have aliased ls to some other command. And then you have to use xargs vi to give that to the vi editor. So the first one is incorrect because two things we have not done. We have not sorted it by time, and we have not used the xargs. So in the second one, what we are doing is we are not using the head. So what we have done is we have done ls -t and directly piped it to xargs vi. So what happens when we simply do ls -t, we get all the files in the sorted order of their time of creation or time of modification. So if I directly give it to vi, so let me demonstrate with echo, you can see it will give all the parameters. So it will basically run vi, b, c, b, a. So this will not open just b, it will open all the 4 files. So that is not what we want. That's why option B is incorrect. In the third option, what we have done is we have done ls -t capital F. So what is the capital F? So if I search for capital F, you can see that this is classify. So append indicator one of */ equal to greater than @ and pipe true entries. So we can also give like optional when, but here we have not given any when. So by default, it will always classify. So if I simply do ls, you can see we are getting A, B, C, D. So let me also actually create a folder E. So if I simply do ls, you can see it is simply printing A, B, C, D, E. So there is no way for us to know whether E is also a file like A, B, C, D, or it is a folder. But if I do capital F, then you can see it will put a / in front of directories. So we can always distinguish what is the type of file just from the name. So this will also give other suffixes depending on the type of file. So if we have, let's say, a executable, it will put a star. If we have a directory, it will put a / I don't know when it will put equal to and greater than. I think pipe is for the name named pipe files. So these are also for the special files like block file, character files, etc. So you can also see if I do mkfifo f and I run this again, you can see for f we are getting a pipe after it because it is a named pipe file. Similarly, let's say I do chmod u plus x on the d file, then you can see that for d we have a star. So this will basically put these symbols so that we can identify what type of file it is. So in this question, we have done ls -tf and then head -1, and we are basically inverse matching all the lines that end with a /. So basically, we only want those files that don't have a / at the end, because that means they are directories. and we don't want to open the directory, we only want to open the last modified file. So we are doing a inverse matching on those, and then we are xargsing into the vi. So why is this not correct? Why is option 3 not correct? What is the issue in this?
Because the head is in the first, so anyway only one element will be taken, right?
Yes, exactly. So if the recently modified thing is a file, this entire thing will work. But if the recently modified thing is a folder, so we just get one line after the head. And then if it is a folder, then grep will remove that. But then we will not have anything in the output at all. So vi will not open any file. So that is not what we want. So that's why what we should do is first we should filter out the folders. So of the output of ls minus tf, first we filter out the folders. Then from the remaining list, we take the first file, and then we xargs it into vi. So that's why the fourth option is the correct option. Okay, so just let me know if this is clear.
Yes, clear.
Yeah. So how the f works, you can see in the help page also. I guess it is given. Yeah, so ls help is given. So we have to see. Yeah, so you can see the f is also given in the question. So you actually are given the man page where you can see what the minus f does. Right, so that's how we solve this question. So let's move on to the next one. Which of the following command prints all the values present in a bash associative array? So this is a like theory question. So if you have an array, how do you print all the elements of an array? We do it this way. So dollar curly braces, name of the variable, square bracket, at the rate, square bracket close, curly brace close. So this way we get all the elements of the array which is named ARR. So hopefully there is no doubts in this one. And similarly, if you want all the keys of the array, then we use the option 3 with the exclamation mark. Right, so let's.
Sorry, I didn't get keys of the array meaning.
So basically, an associative array is like a dictionary. So let's say I create a dictionary. So we can do declare A, and let's say the name of the array is ARR. So if I do ARR equal to, and let's say the name, like the key is the name of a person, and the value is their age. Right. So I can give a few examples here. So now we have this array. So now if I do echo ARR at the rate, so this will print all the values of the dictionary, right? So 18, 21, 22. But if I want all the keys, which is the names, then I have to use it exclamation mark here.
Okay, got it.
Yeah, right? This is like the dictionary in Python.
Yeah.
Yeah. So let's move on to the next question. So here in this question is contents of the current working directory are given. So we are given the current working directory. So we have two folders A and B, and inside each folder we have a few files. So we have file 0, 1, 2, 3, 4 in A, and file 10, 3, 4, 5, 6 in B. So let's see the question. We are asked select all the files that will be present in the current working directory after execution of the following script. So here what we are doing is for I in star. So first we have cd'd into B, right? So we are in the folder which is B. So in folder B, we are doing for I in star. So what does the star in dash do? What will star evaluate to?
All the files present.
Exactly, all the files and folders present in the directory, excluding hidden files. So anything that does not start with a dot. So it will expand to all the files and folders in the current directory, right? So everything inside B. So this for loop will basically iterate over file 10, file 3, file 4, file 5, file 6, one by one. And each name of the file will be stored in the variable I. Right. So next, what we're doing inside the loop is we are doing ls dot dot slash a. So we are currently in folder B. So dot dot means the parent directory, and inside that we are inside the A directory. So we are basically printing all the files and folders present in the A directory. So this will always print file 0, file 1, file 2, file 3, file 4. Then on that output, we are running a grep. So what we are doing grep of $i. So we are searching for that file, which is like the current iteration with present in B, whether that same pattern is present in the output of ls on A. So basically we are checking if, let's say if we are on file 10, so I'm checking if the string file 10 is part of the output of ls on the folder A. So which is obviously not true because there is no file 10 in the folder A. So whenever this is true, so basically whenever there is a file in file B, which is a match or a substring of a file in file A, then what we are doing, so and when this entire thing is working, then what we are doing, we are moving this file from the B folder into the A folder. And so we are basically overwriting that file. So let us see now what will happen. So for each file, so we will go over file 10, file 3, file 4, file 5, file 6. And for each folder, we are seeing if the that file is a match or a substring of any file present in folder A. So file 10 obviously is not a substring or a match of any file present in folder A. So then we move on to the next one, which is file 3. So file 3, you can see, which is present in B, is also present in A. So this grep will succeed and will give a 0 exit code. So then this and then will run this. So we are moving $I from the current directory into the ../A. So I will move the file 3 into the A. So no longer file 3 will be present in our B. So we are now only having file 10 and file 4, 5, 6. So let me paste it here. Okay, so you can see, let me also paste the script. So after the second iteration, so after the first iteration, the file 10 was safe, so we did not move it. But after the second iteration, the file 3, which is also present here, that got moved into the folder A. So the file 3 is no longer present in B. Then the next iteration runs on file 4, and file 4 is also present in A. So this also gets moved. Basically, this gets overwritten by this file, and this is no longer there in folder B. Then we are running on file 5, and file 5 does not match any file name in A. So this remains here. Similarly, file 6 also does not match, so it remains here. So after running all these, in our current directory, which is folder B, we are left with file 10, file 5, and file 6. Right? So the options will be file 5, file 6, and file 10. And no other files are present in the current directory. Yes, hopefully this one is clear how we are arriving at the answer. So all the files that are present in both A and B are also like substrings. So in this case, there is no substring, but imagine we had file 10 in A and file 1 in B. So file 1, even if it was not there in A, file 1 would have matched file 10. So that also would have been moved. But in this case, we don't have. In the forenoon paper, we had that question.
But why will it match?
Because we're using grep, right? So if I have, let's say, echo file 10, and if I am using grep file 1 on this, so this will still match, right? Because grep will always match.
Right. Yeah.
So if like file 1 and file 10 were present in the opposite locations, so file 1 is here and file 10 was there, then that file 1 would also have been moved into the A folder. So that is what we had in the forenoon paper.
Excuse me, sir.
Yeah.
Sir, I had a doubt here. Like when file 3 and 4 are moved from directory folder B to A, then
Yeah.
will they be appended to the existing file 3 and 4 in folder A, or will they be stored with an alternative name? Because in one folder we cannot have multiple files with the same name.
Yeah, so it will be neither. It will neither append nor it will create a different name. It will overwrite that file. So if something was stored, like if these two files had different contents, right? So this file's contents will be lost and this file's content will be stored here.
Got it, sir.
Yeah. Okay, so hopefully this one is clear. So let's move on to the next one. So in this question, we are given a bash script and we are asked select a scenario from the option such that upon execution of the above script, no lines will be printed to the terminal. So what is the script? Here we have a while loop which is reading line by line. So we have while read our line. And for each line, we are matching a regex on this. So we are doing if line matches this regex. So what is the regex? It has to start with a digit, and then there can be any character any number of times, and then there has to be another digit at the end of the line. So the line has to start with a digit and end with a digit, and in between there can be any character, whether digit or not, and it can be present any number of times. So the only criteria is that there has to be minimum 2 digits. Like if the line has a minimum of 2 characters, they both have to be digit. And if not, then the first and the last character has to be digit. Anything in between can be any character. So if the line matches this regex, then we are simply printing that line. And this, we are not taking the input from the standard input, although read will take from standard input, but we have redirected the contents of file 1 as the standard input of this script. So this while loop will simply read line by line from the file 1. And then the output of this, so which is coming from this echo, that is redirected into the file 2. So whichever line matches this from file 1 is stored into file 2. Right. So for example, if we run this script, so let me create a file 1 and a file 2. So I have a file 1 here, and here if I just have digits, so these are digits, and let's say I have a line which is not a digit. So I don't need to have any file 2 pre-existing in a directory. It will be automatically created. So if I run this script, so let me just create a script.sh that I can write this. What are we doing? We are doing while read our line do, and we are doing if the dollar line matches this regex, which is it has to start with a digit, and then there can be any character any number of times, and then again it has to have a digit at the end. So if the line matches this regex, starts with a digit, any character, and then ends with a digit, then echo that line. And if I go run it over the file 1.txt, sorry, I don't have .txt. So if I run it over file 1, so you can see the output. So if I run the script.sh, you can see all the lines of file 1 are printed except the line that has hello. So it can be multiple lines also, and can be present anywhere. Also, if there is like only one number, that will also not match this. So none of those will be printed. So you can see only the lines that have numbers as the first and the last character, they are printed. Now, instead of printing it to the screen, if I redirect the output to file 2, then the output to the screen will always be empty. But now we will have a file 2. Right. So now we have file 1 and file 2. And then what we're doing, we are doing diff file 1 and file 2. So diff is a command that will show the difference between two files. So if I do diff file 1 and file 2, because we are only creating file 2 from the lines of file 1, so we are just omitting some lines. So the diff will basically only show lines that are there in file 1 but not in file 2. So you can see only those lines like world, hello, and 2 are which are not there in file 2 but they're in file 1, those are showed. So when will diff not show any output?
When both the files have same content.
Yes. When both the files have same contents, then diff will not show any output. So for example, if I do diff file 1, then output, there will be no output. So if both the files are same output, that means, so because we are creating file 2 from file 1 itself, so there can obviously not be any other line in file 2 that is not there in file 1. But we also mean that there is all the files of all the lines of file 1 are there in file 2. So that is only possible if all the lines of file 1 match this pattern. So if all the lines are this way, so if we basically remove the offending lines, and then we run the script, and then if we run diff file 1, file 2, then we don't have any output. So this script will not print anything to the screen only if file 1 contains lines that are following this regex pattern. So if all the lines follow this regex pattern, If even one line does not match, then that line will be printed to the screen. So let us see the output like options. So first option is file 1 and file 2 have the same number of lines. So because file 2 we are not reading, we are overwriting whatever is there in file 2. So we actually don't care what is there in file 2. Even if there existed a file 2 which was exactly same as file 1, still it will not matter because we are then overwriting that file, and the script is writing the file 2 on its own. So even if file 1 and file 2 are identical before starting the script, it will still show the difference. So that's why file 1 and 2 having same number of lines is not a correct option, and file 2 being a copy of file 1 is also not a correct option. So even if the file 2 was a copy of file 1 before we ran the script, after we ran the script, the file 2 will have been changed. So it will only contain those lines of file 1 that match this pattern. So that's why the option A and B are not correct. So option C is file 1 is empty. So if the file 1 is empty, then obviously there is no lines to iterate over, and then both file 1 and file 2 will be empty. So diff of two empty files will also show nothing to the screen. So that's why option C is correct, and option D is file 2 contains all the lines that start and end with a number. So this is not correct because whatever file 2 contains does not matter. If file 1 contains all lines that start and end with a number, so if this was file 1 instead of file 2, then this also would have been a correct option. So both these are correct options. Basically, if all the lines of file 1 match the pattern, then there will be nothing on the screen.
I have a question. In case if we say file 2
Yeah.
containing the last option,
Yeah.
wouldn't, whenever the script is run, wouldn't the file 2 be overwritten even in case there's a file 2 existing?
Yes.
Will
Yes.
it not be overwritten? So this will be
Yeah.
true only in case where the file 1 also has the same pattern. That's what I'm thinking.
No, so see, even if the file 2 does not exist and we create it, so file 2 will always contain lines that match the pattern, right? Because that's what we are doing. So we are only the lines of file 1 that match this pattern are stored in file 2. So after the script has
Ah,
run, file 2 will always only contain
correct.
lines.
So
Yeah.
yeah. So it will not copy the lines which are not following this pattern, but file 1
Yeah.
can have those lines.
Yes. So what we have to check is if file 1 matches this. So if all the lines of file 1 are matching the pattern, then both will be identical after the script.
Right. Because not all those lines, even there could be lines which do not follow this pattern in file 1.
Yes. Yes.
Yeah.
Okay. So hopefully this one is clear.
Yes, sir. So single square bracket, can I use
Sorry.
in place of?
Yeah.
Yeah, hello, sir.
No, so not in this case here, because here you're using the regex comparison, right? So you're not doing equals. You're not checking a string with a string. You're checking a string with a regex, right? And checking a string with a regex is only possible inside double square brackets and not single square brackets.
What is the use of tilde here?
So this is the syntax. So if you want to match a string with a regex, then this is the syntax. So equals tilde is how you match a string with a regex. So if you want to match, if two strings are equal, then you use a string 1 equals to string 2, or string 1 equals string 2. Both are same. But if you want to see if a string is matching some regex pattern, then you have to do string equals tilde and then the regex.
Okay.
Right? Yeah. So let's move on to the next one. So in this question, we are asked which all grep commands from the following option produces count of paragraphs, that is total number of paragraphs present in a text file book.txt. Assume that a paragraph always ends with a full stop. So basically we are saying that each paragraph ends with a full stop, and we want to count how many paragraphs are there in a book. So basically, how do we do this with grep?
Just put dot and ends with dot, but you have to escape the dot, right?
Yes, so you have to escape the dot. So if we just put dot, it means any character, both in DID and DID. So we have to escape it. So we have to have backslash dot. So first option is if a line starts with dot, so that is not correct. So and if a line starts with any character, right? So here dot means any character. So we are telling if the line starts with any character. So this will count all lines that are not empty. So this is not a correct. And the second one is simply doing grep dot. So this again is basically all non-empty lines. So this is also not correct. So we have to say all lines that end with a literal dot or a backslash dot. So that is what we are doing. So in this, we are saying if the line has any character any number of times, so this dot is meaning any character, and star means any number of times, including 0. And then we have a actual dot. So we have backslash dot, which is the escape dot. So we have actual dot at the end of the line. Then that is basically meaning that the paragraph has stopped. So then we count how many such lines are there. So we can also directly use the -c flag, or we can pipe the output of grep into wc minus l. So this is the third option. And in the fourth option, basically is the same, but instead of the dot star, we don't have that. So it is exactly the same, because star means 0 or more. So even if there are none, also this will match, and similarly this will also match. So whether we have dot star or not, it will not make any difference. So this will match the entire line, whereas this will only match the dot at the end. But we don't care what is matched, because in the end it will print the entire line, whatever is matched, and then we are simply counting the number of lines. So let me also demonstrate that.
Wouldn't just the dot match, even if there is like there's no proper paragraph as such, but just a dot in, as a separate
Yeah,
line.
that will also be matching, but that will also match in the option 3 also. So basically what you're saying is book.txt. So let's say I have like some, I'm not bothering to type something real. So let's say we have something like this, and then we have a dot at the end, and basically this does not mean end of a paragraph, because the dot is not at the end of the line. But even if, let's say, we have just a dot in a line, this will also match the regex. So here now, if I do grep and this one, so dot star and then actual dot at the end of the line on the book.txt. So you can see it is matching this one, so where the dot is there at the end, and this one, which is just a dot in a line. So both of these are matched. And then obviously if we do the wc minus l, we get 2, which is number of lines. And if we remove the dot star, then also the same lines are matched, but instead of the entire thing being matched, only that dot is matched. But in the end, it does not matter, because we are only seeing the number of lines that is printed. So in either case, it will be 2. So yeah, this will also like falsely consider this as a end of a paragraph. But basically, this is assuming that the book is well formed. So there is no stray dot anywhere. So in that case, it will not count this dot and only count this dot. So this will also, if let's say the last paragraph does not have a dot at the end, it will also basically say that the answer is 1. Right? So it is assuming that the book is well formed. So all the paragraphs have dot at the end, and there is no like a stray dot anywhere, which is not the end of a paragraph. So then it will correctly predict the number of paragraphs to be 2.
So if you remove the dollar, it will give you 3.
Yeah, if we remove the dollar, then we are simply matching presence of a dot. So this will give you even this dot. But the dollar means only at the end of the line. So then we get 2. So hopefully this is clear. So let's move on to the next one. So in this, we are given a test.csv, which has the following CSV file. And we want to select the set script that will remove any hyphens present in the phone number. So here we have phone numbers like this. So as you can see, some phone numbers are this big, some are small, but phone numbers most of the times have hyphen in between them, so that it's easier to read the groups. So what we want to do is we want to remove the hyphens between the phone numbers. So this is the expected output. So as you can see, these are the input and these are the outputs. So there are hyphen in the email ID also. So those hyphens are not removed. Only the hyphens in the phone number, they are removed. So let us see the options that are given. So the first option is we are basically substituting. So this is the backslash and round brackets are groups. So we are substituting one digit followed by a dash, and then 3 digits followed by a dash, and then 3 digits followed by a dash, 4 digits, and we are substituting it with the 4 groups. So all the digits without the dash, and then we are substituting 3 digits followed by a dash and followed by 4 digits. But here the order of replacement is 2 and 1, right? So here it is incorrect. So basically, if we have phone numbers of this, which is 4747526, the output instead of being 4747526 will be 75726 So that's why this is incorrect. So in the second one, we are simply removing all the dashes, which is not correct because it will also remove the dashes from the email ID, which is obviously not what we want. So the third and fourth options are correct. So in the third option, we are substituting all, like if there is a 1 digit followed by hyphen followed by 3 digits followed by hyphen followed by 3 digits followed by hyphen followed by 4 digits. So this is one of the patterns, as we have seen, these long phone numbers, and another pattern is 3 digits followed by hyphen followed by 4 digits. So for the first one, we are basically substituting that with group 1, group 2, group 3, group 4. So these are the digits. So we are removing the hyphens. And in the second one, if there is 3 digits followed by hyphen followed by 4 digits, so we have grouped the digits and we are substituting that with only the groups. So group 1 and group 2. So here the order is correct. So that's why this is a correct option. And the second one, this is a more general or generic solution. So instead of relying on the pattern of the phone number, so if tomorrow there is a different pattern, then this will not work. But this here, yeah.
Sorry to interrupt. With the option number 3, there is
Yeah.
no G at the end. So it will only
Yeah.
do it for the first options that you get, right?
Yeah, so it will do it only for the first phone number, but assuming that the file is structured, you will only have one phone number, right, in each line, because this is name, phone, email, region. So if you get one such in each line, that is enough. You don't have to use G in this.
So said will go line by line. So it will take each line at a time, and then
Yeah.
wouldn't it
So,
not take one selection in the entire file, the very first selection, because we haven't said G, like globally change it?
no. So that is not how G works. So said substitution will do one, like the first occurrence in each line. And if we do G, then it will do the substitution for all occurrences of each line. So that is
Okay.
like very
Yeah,
important.
understood.
Yeah. So for example, if I have data.txt here, and let me just demonstrate this for the sake of clarity. So if I do sed substitute hello with Ola on this file, so you can see it will substitute the first occurrence of each line. And if I give a G, then it will substitute all the occurrence of each line. So if there are multiple
Yeah,
hellos
so
also,
basically each line, it'll iterate through each line and then
yeah.
do the respective task.
Yeah. So whatever command that we have, it will be done on each of the lines one by one. So here, if it runs once for each line, that is fine because we only have one phone number each line. So this is a customized for the formats that we have.
Yeah, understood. Because G was the only problem. Now that you explained, I got the
Yeah.
concept.
And the option 4, this is a generic option. So here what we are doing is, if there is any digit followed by a hyphen followed by any digit, so we are simply substituting that with the first digit and the second digit. So we are simply removing the hyphen. And here we have a G. So what we are doing here is basically, like we have 3 matches here, right? So 1-1 is one such regex, 8-6 is one match, and then 2-4 is another match. So here we have n-r. So this is not a digit followed by hyphen followed by digit. So this is not matched. Only these are matched. And in all the matches, what we are doing is we are simply removing the hyphen. So we are substituting them with the group 1 and the group 2. So this is a better approach because tomorrow if there is a different pattern of phone number, which is like having a different grouping, then option 3 will not work for that, but option 4 will work for any such pattern. But another place where this will not work is if your email ID is of that pattern itself. So let's say if this person's email ID was madan1-2 raja, then it would have replaced that with Madan Raja, which is not correct. So both has their ups and downs, but both will work for all the data present in the example.
So that we can do like email address as a presence of @ symbol, right? So we can first search for that, and we can do like maybe
Yeah.
Yeah,
We can do that. Like basically, but then we have to see that the @ is not part of that field. That is part of some other field. Yeah. Hopefully, this is clear how this is working. So let's move on to the next one. So in this question, what is the question? Yeah, we have this CSV file, similar CSV file as earlier, and we have to, what we have to do is we have to select the awk command that will produce the output as shown below. So we are taking the name followed by a colon, and then the number followed by colon, followed by the email address, and the like state is omitted, and then we have an empty line before the next record. So each record will give us 2 lines, and here we are only having the first 3 fields. So let us see the options. So the first option is we are setting the field separator as comma, that is required because this is a CSV file, and then for each line we are printing the $1 and then concatenated with colon, then $2 concatenated with colon, and then $3 followed by a new line. So print itself will print a new line always, and because we have a new line in the argument itself, so there will be 2 new lines. So the entire thing will be printed, then a new line will be there, and then it will go into the next line. So here we are simply printing the first 3 fields, and we are separating the fields by comma, and in the output we are separating the fields by colon. Right, so let's see the next option. So here we have begin, and we have set the fs to be comma. So instead of using -f, we're using fs comma and ofs colon, and ors new line. So ors anyway by default is new line, so setting it to new line also does not make any change. And we're doing print $1, $2, $3. So if we give print $1, $2, $3, so it will not print a comma between them. It will use whatever is the OFS. So in this case, it will correctly print $1 colon $2 colon $3 because the OFS is colon. But the issue is because the ORS is \n and we have not given a \n here, so it will only print one new line. So this empty lines in between will not be there. Everything else will be correct. So the order of the fields is correct, and the colon in between them is also correct, but there is no empty lines. So the third option is same as the second option, but instead of \n, the ORS is \n. So this is correct because after each record, we want 2 \n's, one to go into the next line and another to leave this line as empty. So everything else remains the same as option 2. So fs is comma, ofs is colon, and ors is \n. And we are printing only the first 3 fields. And similarly, in the fourth option, the fs we have provided using the -f, same as option 1, and ofs we have set as colon. And here we are printing $1, $2, $3 concatenated with the new line string. So we have not set the ORS to be double new line. It is single new line, but in the print itself, we have given a new line. So this will print one new line, and by default, ORS will print another new line. So this will also give you the correct output. Just let me know if this is clear, why option 1, 3, and 4 are correct.
Clear, sir.
Yeah. Okay. So let's move on. So in this question, for the given regular expression, identify the correct statement from the following option. Note that EID is used. Hint, a group number starts from the outer to inner and left to right. So here you can see we have nested groups, right? So inside one group, we have another group. So in nested groups, the outer one gets the lower number and the inner one gets the next number. So in this, we start with outer group. So this outer group is group 1. Then this inner group, which has just one character. So any character, dot means any character. So one any character, this is group 2. Or, so this pipe means or. We have another group. So this is now group 3. followed by the group 3 again, right? So any character followed by that same character. That is what this means. And then again we have a or, and then again we have any character in a group. So this is now the fourth group. So we have fourth group followed by again any character, and again followed by whatever were present in the fourth group. So if this was the letter A, this also has to be the letter A, and the middle one can be any letter. So basically, what are we matching in this? What does something like this mean? If we have one letter and then another letter and then again the same as the first letter, what does a string like this mean?
Palindrome something.
Yeah, palindrome, right? So if we have basically, if the string is same from the left to right and right to left, so
Anagram.
yeah, so palindrome numbers. So palindrome text. So in this, we have three regexes. One is just one character. So obviously, if you just have one character, that is a palindrome because there is only one character. And in the second one, we have a character followed by the same character, right? So any character present two times. And the third one is any character followed by any other character and then followed by again the same first character. So this is also a palindrome. So things like noon, anna, etc. But these are 4-letter palindromes, whereas here we are only matching 1-letter, 2-letter, and 3-letter palindromes. And this has to be the entire contents of the line. So we have the start of the line and end of the line at the left and right of the regex.
Sir,
So
here which one is /1, 2, 3? How to count? Because there are multiple.
yeah, so
open and
that's
close brackets.
what we did, right? So if it is also mentioned in the question, so the counting is always from outside to inside and from left to right. So the group number starts from outer to inner and left to right. So the first one is this outer one, right? So this is group 1. So this entire outer thing, this is group 1. Then the inner one gets their number. So then it is from left to right. So this is group 2, then this is group 3, and this is group 4.
Okay, that's why we are saying /4. Okay, makes sense.
Yeah. So this is 4, so that's why we're doing \4 after this. Right. So then this is the regex will match with one character palindrome, which is true. So the first one will match that. Then this regex will match 2-character palindrome, which is also true for the second one. And this regex will match 3-character palindrome, which is true for this one. And this regex will match 4-character palindromes. So this is not true because we don't have any 4-character palindrome matching regex. We are only matching 1, 2, or 3-character palindromes. And so hopefully this is clear how we are getting this. So let's move on to the next one. So here we have a student named Meena wrote a shell script xargs.sh, says that every time main.py is changed, that is, there is a change in the modification time, the shell script is executed on Python script file. So here what we are doing is we have a shell script, so shebang user bin bash, and we are running a for loop. So we are running we are running a while loop and we are running an infinite while loop. So we are running while true. So true is a command that will always return exit code 0. So this will always run. So inside that while loop, what we're doing is we are using the stat command to get the last modified date. But I think the stat %w may be wrong. So let's see that. So if you see man stat, so you can see that this -c will basically use any format that you give, and it will give the output of the stat in that format. So let us also see the formats. So here W is the time of file birth, second since epoch. So this is when the file was created. Whereas we don't want to see the time of creation of a file, but we want to see the time of modification of a file. So for example, if here let's say I have this file, right? So file 1. So if I do stat -c %w file 1, so I get this value. Now, if I change this file or I simply touch this file, so touching a pre-existing file simply updates its modification time. So now you can see the stat -c %w is still the same because this is the time of creation of a file and not modification. So if I want the time of modification of a file, then we have to basically see which format specifier does that. So let me search that. Yeah, so you can see time of last modification, human readable, time of last modification, seconds since epoch. So this will basically be like something we can understand easily, and this is seconds from 1st January 1970. So if we use Y, so you can see this is the time at which this file was last modified. So 8:07 p.m. 40 seconds, basically a few seconds before. So we recently only touched it. And we can also use the capital Y to directly get the seconds. So now you can see this is always the same, but as soon as I touch it again with touch file 1, then this changes, right? So now the value changes. So we want to use the percent capital Y or the percent small y and not the W. So this is one thing that is wrong in this. So this basically what the question asks is find out what are the errors in the script. So this is one of the error that Meena is using percent W instead of percent Y. So stat minus C percent Y or percent W of $1. So $1 is the first argument given to this script. So we will pass the name of the file to this script as the first argument, and we are basically using stat to get its last modified time, and that we are storing it in a variable lmt. So then what we are doing is we are comparing if lmt is lesser than plmt. So LMT is the last modified time and PLMT is the previous last modified time. So as you can see at the end of the while loop, we are basically setting PLMT to be LMT. So basically we are always setting the PLMT to be LMT, and we are checking if in the next iteration, the value of LMT has changed from the last iteration. So if you're using LT, so we are seeing if the last modified time is less than the last modified time of the previous case. So this can never be true. So it will either be same or it will be greater than. Right? If we are checking the seconds, then it will either be more than the previously modified modification time, or it will be same. So this is also another mistake. So this has to be either be greater than GT, or we can use does not equal to. So exclamation mark equals to. So then what we are doing is we are clearing the screen, and then we are printing the like current day, hour, minute, second, and we are printing started. So and then we are running the script, but instead of using $1, we are using $2. So this is another mistake here. So we should run the file which is given in argument 1 and not argument 2. So this is the third mistake. And then again we are printing at the time at which it has ended, and then we are setting PLMT to be LMT. So again, for the next iteration, we are basically updating the value of PLMT, so that in the next iteration, if LMT again is different from the current value of LMT, then we will again run this. And then we are sleeping for 1 second. So we don't want the infinite loop to take up all the resources of our system. So usually when you have an infinite loop, you should have some delay inside. So here we have a 1 second delay. Okay, so then we are also told how this is executed. So this is executed this way: /exam.sh main.py. Right. So the name of the Python file is only given 1 as argument 1. It is not given 2 times in argument 2. So this is incorrect. This should be $1. So then we are also told the stat, how it works. Right. So here we are told this one. So percent y is what we want, and not percent w. So percent W will give you time of birth, whereas percent Y will give you time of modification. So then the question is, what are the errors in the files? Apparently, a code has some issues. Identify all the flaws from her to facilitate debugging of the script. So first option is incorrect interpreter on the first line. So on the first line, the interpreter given is shebang user bin bash. So this is a correct path to the bash executable. So this is not an issue. So next option is incorrect condition in the if statement. So this we already saw. So this is incorrect in the if because we are using less than. So obviously if we update a file, then its modification time will only increase and not decrease. So this LT will never be true. So that's why this is condition is incorrect in the if. So next is incorrect assignment to the variable LMT. So this also we saw that the assignment of LMT, we are using percent %W instead of percent %Y. So that's why the assignment of LMT is also incorrect. So So the third option is incorrect assignment of variable PLMT. This is not an issue because we have correctly set PLMT to be equals to LMT at the end of the while loop. So we are correctly storing the LMT as the previous LMT. And the fourth option is, the fifth option is incorrect execution. The proper Python file execution should be Python 3 $1. Right? So this also we saw, instead of $1, we have given $2 there. So that's why this is also a correct option. And finally, the fifth is the same as the above, but it's telling instead of Python $1, we should just say $1. So this is obviously not correct. To run a Python file, we have to run it with Python and then the name of the file. So that's why these are the errors in the code which should be fixed. Just let me know if all of these are clear, how we are getting these.
Yeah, this is clear.
Okay. So let's move on. Okay. So the next question is, which of the following commands will print only the lines 4 to 6 ends inclusive and the lines 10 to 15 ends inclusive of a text file test.txt? So we have to use sed and print the lines 4 to 6 and 10 to 15 of a file. So usually how will we do this in sed? So for example, let's say I have a like A to Z. ABC. Right. So I have this file ABC which has all the letters A to Z. So if I want only from what are the lines 4 to 6, so I want D, E, F, and I want the lines 10 to 15, which is J, K, L, M, N, O. So how can we do that in sed? Only print some lines.
Can we use nr function, nr substitute everything nr outside that to blank?
No, NR will work in awk, right? In sed we don't have NR.
Sorry. Yeah.
How can we do that in sed? So conditionally for some lines, how can we do some command?
So we have to give a pattern, like somewhere like within pattern search, we have to give what you're looking for.
So the content of the file can be anything. So we cannot use pattern search. I want only line 4 to line 6. So I want to condition on the line numbers and not the text.
The tilde 2:3 I 2 commas.
We'll provide a range.
Yeah. So how do we do that?
B.
Sorry, can you repeat that?
5, 7.
Yeah. So here we want 4 to 6. So what will we write?
Slash
4
or slash
6.
No. If we have /4, this means we are searching for the number 4 in the file, which is not present anywhere in the file, right? We want line number 4 to 6.
after
4
this
tilde
there will
6.
be a comma.
No, 4 tilde 6 will also not work. So what this means is from the 4th line, every 6th line. So we don't want that.
Okay. Then 4 tilde 1 6.
Your voice is breaking, so I'm not able to hear what you're saying. So basically, what you do here is like when you want to address from one line number to another, you simply put a comma between them. So here we want 4, 6. So we want to print the lines from line 4 till line 6. So then what is the command to print those lines?
P.
Yeah, P. So if I do this, will it print only lines 4 to 6?
We'll have to provide the file name.
Yeah, if I do this, then will this work?
Yes.
Are you sure about it?
I think so it will work.
Yeah, so this will not work because we have not given the -n, right? So each line will be printed once and these lines will be printed 2 times. So you can see we will have something like this. So D, E, F, they are printed 2 times, others are printed once. So whenever you want to selectively print something, remember you have to obviously stop the default printing, right? So you have to use -n. So now we are getting the correct, which is DEF. And similarly, we also want to print the 10 to 15. So how can I give another thing here?
E.
Yeah, we
We
can
can give a
use E.
pipe after 4 to 6. We can give a pipe and then 10 tilde 10 comma 15.
No, a pipe will not work. What we can do is we can use a semicolon here. So I can use 10 comma 15p. So this is correct. This will give me the output. Or as she was saying, we can use minus e also to give multiple like scripts, which is 10 comma 15p. So both are correct. So you can either give multiple scripts with minus e, or you can in one script you can put a semicolon and give multiple lines. Right, so this is basically how we will print 4 to 6 and 10 to 15 and not print anything else on the file ABC. So that is basically the answer. So another way is we can, instead of using minus n, I can simply ask it to not print the other lines, right? So if I want to print 4 to 6 and 10 to 15, I basically don't want to print 1 to 3. Right? So I can say 1 to 3, I will drop them. So if I do this, then we can see everything from after 4 we are printing. So similarly, if I basically want to print 4 to 6 and 10 to 15, then 7 to 9 also I have to drop. So then I will give another thing. I will give 7 to 9 drop. Right, so now this will drop before 4 and between 6 and 10. But I also need to drop after 15. Right, so then we can give 16 comma dollar. So dollar basically means the last line. So from 1 to 3 drop those lines, from 7 to 9 drop those lines, and from 16 to end of the file drop those lines. So minus n by default prints line, so D will drop those lines, and the ones that are not listed here, those range will be printed. You can see this will also give you the correct answer, DF, JKL, MNO. So this is one way. We don't remove the minus n. Sorry, we don't add the minus n. So by default, all the lines are printed, and we delete the lines that we don't want. And another way is using minus p and specifying the lines which we want. So I want 4 to 6 print those lines and 10 to 15 print those lines, or print all the lines but remove 1 to 3, 7 to 9, and 16 to end of the lines. And the second one is incorrect because it is doing this without the minus n. So as we saw, it will print things 2 times. And the fourth one, we are doing same thing. So we are, instead of semicolon, we are doing it separately, but we have not given the minus n, right? So here also minus n is missing. That's why this is incorrect. So the first option and the third option are the correct options. So you can either drop the lines you don't want, or you can drop all lines and then print the lines you want. Right, so hopefully this is clear. So let's move on to the.
What would be the output if we use hyphen instead of comma?
Hyphen is, I don't think, is a valid syntax. So for example, let's see this. So we are getting DEF. If I use hyphen, then we will get an error. So this is not a valid syntax at all.
Oh, so hyphen does not work in
So,
Z, right?
no, yeah. Only you can use comma.
Okay. And what if I want
If you
to
want,
print only
yeah,
4th and 6th line?
yeah, then you have to basically do 4p and 6p.
Okay.
So now let's see the next question. So in this question, we basically are doing brace expansion. So let me zoom in. So the answer is not visible. So here we are doing brace expansion. So we are doing A, B, C, C, and C, C, E, F. So what happens when we are doing brace expansion without any space between them is we get a combination, right? So these are 4 outputs and this is 4 outputs, and we'll get a combination. So we'll get 4 into 4, 16 outputs. So we'll get AC, AC, AE, AF. Then we'll get BC, BC, BE, BF. Then CC, CC, CE, CF, and CC, CC, CE, CF. Right, then what we're doing is everything will be printed one after the other with space between them. So let me also run this. So you can see if I do echo A, B, C, C, so this will simply print A, B, C, C. If I give a space and then I put C, C, E, F, then it will expand this and this independently. We'll get A, B, C, C and C, C, E, F. But if I put this together without any space, then it will take a combination of them. So we'll get AC, AC, AE, AF, BC, BC, BE, BF, CC, CC, CE, CF, and CC, CC, CE, CF. Right. So now if I do a PR of space with new lines, I'm replacing space with new line. So same thing, instead of coming side by side, will be separate lines. So now you can obviously see that there are some duplicates, right? Because we have same letters here and we have also same letters here. So what we are doing now is we are passing it into sort and unique. So first we are sorting the output. So all the duplicates are side by side. So as you can see, all the ACs are side by side, BCs are side by side, and the CCs are also side by side, and CECF also side by side. So then we are using the unique command to remove all the duplicates. So we are only getting the unique entries. And so we are only getting the unique entries. So after that, what we are doing is we are running awk, and you're running this awk script. So what we are doing for each line, we are doing n plus equals nr. So what is nr here?
Number of record.
Line number.
Yeah, the line number, right? So for each line, it will be the line number. So what will be the values of nr for like this output for each line?
So it will be 1 for each, basically, and but NR will keep increasing, right?
Yeah.
For AC it will be 1, for AE it will be 2, AF it will be 3.
Yeah,
like
so it
that.
will be basically like 1, 2, 3, 4, 5, 6, 7, 8, 9. So there are 9. So it will be 1, 2, 3, 4, 5, 6, 7, 8, 9. And what we are doing is we are simply adding the line numbers. So we are doing 1 plus 2 plus 3 plus 4 plus till 9. So, and in the end, we are simply printing that value. So the output of this is basically adding all the numbers from 1 to 9.
So it will 45 or something like that.
Yes, so it should be 45. So if I do, so what is the formula for that? I think 9 into 10 by 2. Yeah, so we get 45. So the output for this is 45. So here also you can like do it on pen and paper, because obviously you cannot execute it in the exam. So you cannot see how many are there. So you can simply see that what we have is A, B, C, C, and we have C, C, E, F. So you can basically write down all the combinations, which is AC, BC, sorry, AC, AC, and then AE, AF, and then BC, BC, BE, BF, and then CC, CC, CE, CF, and then again CC, CC, CE, CF. So then you can simply like manually count how many unique there are. So this is one, and then
we don't have to enumerate it because we saw there is a unique and sort and unique.
Yeah.
We know it will be unique. So you to if I ABCC, that C is duplicate. So basically I can get rid of one C. And then similarly in second also I can get rid of one C. So it's a 3 cross 3. So I'll know I'll get 9 outputs, and that's it.
Yes,
And then
yes,
we are adding up all the numbers from NR. So it will be 1 plus 2 plus 3 up to 9. That's it.
Yeah, exactly. So it'll basically.
The question will be, if instead of NR, if you have FNR, the answer will be 9 instead of 45.
No, FNR will still give you 45 only, because either way, this is only one file. So we are giving only the standard input.
FNR resets every time, right?
Yeah, so if there are multiple files, but we are not giving any file, right? We are giving standard input. So it is just one file. So either way, it will give you the same thing. So we can also see that. So if I simply print the NR for each line, you can see it is 1 to 9. If I print FNR also, it is 1 to 9. Because it is just the standard input. So that is also considered one file.
Oh, right. It's being given in one go, that's why. Not sequentially. Because the entire echo is actually one. So there are 9 lines. Yeah, got it.
Simplified. So there are 9 lines, because then we are using TR to make it 9 lines. But this entire thing is only given a standard input, right? So it's not like we have given file 1, file 2, file 3.
Correct.
Yeah. So if this was done with xargs, then it would basically try to read file 1, file 2, file 3. So it would be having 9 parameters. But we're directly passing it into awk. So we have FNR or NR both going to 9.
Variation of this question will be a 3-way. Let's say you have ABCC, CCEF. You can do one more like GH, HQ, whatever it is, right? We don't have to enumerate. We can actually tell what the answer would be.
Yeah, we just remove the duplicates from
Duplicates and then multiply. That's all.
Yeah. So hopefully this is clear for all. Now we are getting 45. So that is the end of this paper, which is 23 Jan AN paper. So we have done 23 Jan FN paper on Saturday, and we have done 23 Jan AN paper today. We've also done 23 May papers. So next days we will do the 2022 papers. So we have 3 into 2, so 2 shifts. So we have 6 papers. So we'll do them on the Thursday, Friday, Tuesday, Wednesday, Thursday, Friday. So let me stop recording.